The beginning of this lesson will seem a little weird, but if you follow along, by the end, this should make sense. The first thing that you're going to have to do to understand trigonometric ratios is memorize the following acronym. SOH, S-O-H, CA, C-A-H, TOA, T-O-A. So memorize SOHCAHTOA. SOHCAHTOA stands for this. S is sine, O is opposite, H is hypotenuse, hypotenuse. CA is cosine, adjacent, hypotenuse, hypotenuse. TOA is tangent, opposite, adjacent. Now SOHCAHTOA helps you memorize the trig ratios. The first trig ratio is sine of theta. Now theta is an angle. We don't know how big the angle is, so in our ratio we're just going to put a variable. Theta is a Greek letter, and it's just going to be replaced with the angle that we're going to use. So sine of theta, sine of the angle, equals, now here's your ratio, the opposite side of the triangle over the hypotenuse. So, S-O-H. Cosine of theta, cosine of my angle, equals the ratio adjacent side over hypotenuse. CA, C-A-H. And finally, tangent of theta equals the opposite side over the adjacent side. So memorize SOHCAHTOA to help you remember these trig ratios. Once you have the trig ratios memorized, we can apply them to solve some triangles. In example 1, we know that this angle right here is 28 degrees. And we know that this side is 17. If we know an angle and a side, we have enough information to solve for the two missing sides using trig. First thing, we need to identify all three sides of my triangle. Across from the right angle is my hypotenuse. Now I know about this angle, 28 degrees. Across from my 28 degree angle will be my opposite side. Now there's actually two sides adjacent to my 28 degree side. But this side is already my hypotenuse, so this side right here will be my adjacent side. Now we need to look. In this problem, in this example, we know the hypotenuse. Since we know the hypotenuse, that's going to tell us which trig ratios to use. So if we look, we need to find the trig ratios that have the hypotenuse in them, and that is sine and cosine. Since we know the hypotenuse is 17, I'm going to pick these two trig ratios for example number 1. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And again, I picked these two because I knew the hypotenuse. So let's plug in what we know. Theta is going to be replaced with my angle, 28. The opposite side is going to be replaced with x, and the hypotenuse is going to be replaced with 17. And I can do the same thing here with cosine. Adjacent side is y, hypotenuse is 17. At this point, I just need to solve for x and solve for y. It becomes an algebra problem. Now if we look, on the right side of my equal sign I have a ratio. On the left side, I want to make the left side a ratio also. Now I have a proportion. And to solve a proportion, I can cross multiply. Drop my equal sign straight down. I have 17 times the sine of 28 degrees equals x. So x equals 17 times the sine of 28 degrees. So how do I finish the problem? Well, it turns out that all triangles that have a right angle and a 28-degree angle are similar to each other. So there's always a proportion that relates the opposite side to the hypotenuse. So if I know that I'm dealing with a 28-degree angle, I can use a trig table to find out that ratio. If I flip to the page before, I have a big trig table. So I'm going to use the sine column, and I want to find the sine of 28 degrees. The sine of 28 degrees is right here, 0.4695. So I can replace from my table sine of 28 degrees with 0.4695. And since this is actually a rounded answer, this is going to be my approximate x value. So now I need to use a calculator. 17 times 0.4695. Now when I round to 1 decimal place, this 8 makes this 9 a 10, so x is approximately 8.0 long. I can do the same thing to solve for y. Turn my left side into a fraction, so now I can cross multiply. 17 times the cosine of 28 degrees equals y. So y equals 17 times the cosine of 28 degrees. Use my trig table to find the cosine of 28 degrees. Cosine is my second column after my sine. 0.8829. So I'm going to replace cosine with 0.8829 and use my calculator to do that math. Round to 1 decimal place, I get about 15. So y is approximately 15.0 units long. Let's try another example. Let's look at example 2. First thing I need to do is find the angle that I know. Then I need to label all 3 sides of my triangle as hypotenuse, opposite, and adjacent. Now in this case, I know the adjacent side. So I want to pick the 2 trig ratios that have adjacent in them. And they are cosine and tangent. So let's plug in what we know. The cosine of 35 degrees equals my adjacent side over my hypotenuse. The tangent of my angle equals the opposite side over my adjacent side. Once I have my values plugged in to the trig ratios, again it's an algebra problem. I want to turn my ratio into a proportion and cross multiply. So this time I get x times the cosine of 35 degrees equals 8. Notice how this problem is different than the first example. In the first example, my variable was in the numerator. Now my variable's in the denominator. When I cross multiply, my variable is on the left side. So in order to solve for x, I'm going to have to divide both sides by the cosine of 35 degrees. So x equals 8 divided by the cosine of 35 degrees. Again, I'm going to use my trig table to find out the cosine of 35 degrees. The cosine of 35 degrees, 0.8192. So I'm going to replace cosine of 35 degrees with my decimal approximation. And then do my math using my calculator. 8 divided by 8192 gives me approximately 9.8. So x is approximately 9.8 units long. Solve for y in my second ratio. Cross multiply. I get 8 times the tangent of 35 degrees equals y. So y equals 8 times the tangent of 35 degrees. Notice that I don't have to divide in this problem. Use my trig table to find out approximately how big the tangent of 35 degrees is. The tangent of 35 degrees is approximately 0.7002. Use my calculator to do that math. 8 times 0.7002 gives me the answer approximately 5.6.